All right, welcome folks. We're back over here and we're reviewing our homework checker this time. The problem is we're going to find all extreme values for f of x equals the natural log of x squared on the interval of -1 to 2. And if we notice here, it's a closed interval. Okay. So if we recall, our extreme values are the values which we have to find f prime of x is 0. It's also where another possibility is where it does not exist. And we also have to check the endpoints of the function. Okay. So the extreme values are just the high and the low points of the function. And now we're going to do this in two separate ways. We're going to do it with calculus, and we're also going to do it just with pre-calculus as well. Okay. So the first thing we're going to do is we're going to check here where f prime of x is equal to 0. So let's go ahead and do so. So we get, we're going to take the derivative. There's no need to rewrite this. So we're going to say f prime of x is, we're going to use the power rule, so it becomes 2 times ln of x times, or to the 1 times the derivative of the inside function, which is ln of x. We rewrite this as 2 times ln of x times the derivative of ln, which is 1 over x. And so we get f prime of x is equal to 2 ln of x over x. And now we're going to set it equal to 0. And at this stage here, to solve this, we would simply multiply by the denominator here, and these cancel out, and I'm left with 2 ln of x equals 0, and now I divide by 2, and then natural log of x is equal to 0, and now we're going to transpose it, so base to the answer equals the middle, and e to the 1, anything to the 0 is going to be 1, excuse me, e to the 0 is going to be 1, so x is 1, so we have one critical value, we have one critical value here of x equals 1 for this. And this is just where f prime was equal to 0. So that's one possible extreme value that we're going to find. So the next thing we're going to find, we're going to check now, is where f prime of x doesn't exist. So for that one, you basically have to check. You have to check to see, does my denominator equal 0 anywhere? So in this case, does my denominator equal 0 of
Can I read Clark?
Can
I read Clark to the front gate, please? Thank you.
So the denominator of, if we recall, f prime of x was equal to 2 ln of x over x, and my denominator was just x. So if we set this to 0, this value here, this is where f prime of x does not exist, because it does not exist at 0 because I can't divide by 0. So that's another extreme value we have to check. So we have 2 so far, and now we also have to check our endpoints of -1 and 2. So far we have, for the function f of x equals the natural log of x squared, we have x equals 0, x equals 1. We also have to check the endpoints of x equals -1 and x equals 2. So we're going to basically find all our extreme values and the absolute max and min as well. So let's go ahead and do so. So we have this here, and when we plug this in, so we're going to find f of 0 for the height. So ln of 0 squared, and we have a problem here because there is no ln of 0, so this has no solution, which means that this over here, 0 is out. X equals 0 is out. The next thing that we're going to do is we're going to plug in 1 into the function, f of 1, ln of 1, and we're going to square that. ln of 1 is 0, 0 squared is 0, so 1 point so far we have for my answer. So my extreme values is going to be x is 1 and then y was 0. Next one is negative 1. Negative 1. And we're going to get the natural log of negative 1. We're going to square it. The problem is ln of negative 1 has no answer. And if I square that, that's no solution. So because the y value had no solution, that means this value is also out. And now we're going x equals 2. And so f of 2 is going to be ln of 2, the quantity squared, which is going to be, I'm not sure exactly. We'd have to get a calculator for that. But we're just going to leave it as ln of 2 squared. So the next extreme value is going to be 2, comma, ln of 2, the quantity squared. Okay, that would be the corresponding y value. And these are my extreme values here.